Welcome to an interesting lesson on the group 70 elements, popularly called the halogens. The halogens are the elements in the group 17 of the periodic table. The word halogen means salt former. These elements are in the second column from the right in the periodic table, and they are fluorine, chlorine, bromine, iodine, astatine, and tennessine, an element that is prepared in the lab. Don't forget to subscribe, like, comment, and share this video. I must say that I am very happy with my viewers and my students. You always subscribe, and I appreciate you for that. The objective of this lesson: by the end of the lesson, the student should be able to identify the group 17 elements of the periodic table, write their electronic configuration, describe their periodic trends, and identify the oxidation state of some of the compounds of the group 17 elements. It is important to state that tennessine is a radioactive element created in the lab. It decays quickly, so many of its properties are not known. Therefore, we'll be considering only the properties of fluorine, chlorine, bromine, iodine, and astatine in this lecture. The physical state of fluorine. Fluorine exists as a gas, chlorine exists as a gas, bromine as a liquid, iodine as a solid, and astatine as a solid. So we can say that the halogens are the group of elements that can attain the three states of matter: gas, liquid, and solid. The atomic number. Fluorine is 9, chlorine is 17, bromine is 35, iodine is 53, and astatine is 85. For their atomic mass in gram per mole, for fluorine is 18.99, chlorine is 35.45, bromine is 79.9, iodine is 126.9, and for astatine is 210. These halogens can exist as isotopes. For fluorine, it has one isotope fluorine 19. Chlorine has two isotopes, fluorine 35 and fluorine 37. Bromine has one isotope, bromine 79. Iodine has one, iodine 127. And astatine can exist in three isotopes: astatine 209, astatine 210, and astatine 211. It's important to know that astatine can exist as three isotopes, and chlorine exists as two isotopes, fluorine 35 and fluorine 37. Their electronic configuration is ns2np5, meaning that they have 7 electrons in their outermost shell. They need 1 electron to obtain the octet and ideal gas configurations. Halogens are the most reactive nonmetals in the periodic table. This is due to their tendency to pick up or share an electron to achieve an octet or closed inert gas. The electronic configuration for fluorine is He, that is the helium structure, He, and 2s2, 2p5. For fluorine, Ne, neon, 3s2, 3p5. For bromine, argon, 3d10, 4s2, 4p5. For iodine, krypton, 4d10, 5s2, 5p5. And for astatine, xenium, 4f14, 5d10, 6s2, 6p5. The properties of the group 17 elements continues with their melting point, boiling point, radius, atomic radius, ionic radius, ionization energy, electron affinity, and electronegativity. All elements of this group are diatomic and molecular, and the melting and boiling point increases as a result of increasing van der Waals forces. Interaction between diatomic molecules For the heavier elements compared with group 16 elements, halogens have relatively low melting and boiling points. Halogens achieve an octet by gaining an electron to form an ion, negatively charged ion. Hence, their ionic radii will be bigger than their atomic radii due to the addition of more electrons. Ionic radii increases due to the increasing number of quantum shares. We found out that the atomic radius increases down the group. The ionic radii also increases down the group. First ionization energy decreases down the group. Electron affinity increases down the group, and electronegativity decreases down the group, keeping fluorine as the most electronegative element. Occurrence of the group 17 elements. The halogens do not exist in their free state. Chlorine is the 20th richest element found by weight in the Earth crust, containing 0.031%. It exists in a gaseous state at room temperature, while fluorine is the 13th richest element by weight in the Earth crust, containing 0.06%. It usually exists as insoluble fluorides, cryolites, fluorspar, and fluorapatite, found in the soil, plants of stream water, bones, and teeth of creatures. Dried beds of the ocean. Bromine is a liquid containing 0.00016%, and iodine is a solid containing 0.00003%. They are present in the ocean water as chlorides, bromides, and iodides. Astatine is found in solid state and the rarest naturally occurring element on Earth. Below are their colors as shown on this slide. Their common oxidation number. The oxidation number in simple terms can be described as the number that is allocated to elements in a chemical combination. The oxidation number is basically the count of electrons that atoms in a molecule can share, lose, or gain while forming chemical bonds with other atoms of a different element. If the oxidation number is positive, then this means that the atom loses electrons. And if it is negative, it means the atom gains electrons. If it is zero, then the atom neither gains nor loses electrons. You can see that fluorine can exist as -1 oxidation number, and some examples are shown. We also have chlorine can exist as -1, +1, +3, +4, +5, +6, and +7. That means chlorine can combine a lot. Remember we said that if it is positive, it means that it loses electron. So chlorine can lose electrons. And if it is negative, it means that it can gain electron. Bromine can also exist in 5 oxidation states. Iodine can exist in 5 oxidation states, and astatine can exist in 5 oxidation states. So the members of this group can exist as -1, 0, +1, +3, +4, +5, +6, and +7. The example of their compounds where they exhibit these oxidation numbers are shown. Oxidizing power of the halogen. Oxidation is the loss of electrons. Each of the elements, for example chlorine, could potentially take electrons from something else and are subsequently ionized, which has a Cl-. This means that they are all potential oxidizing agents. Halogens are great oxidizing agents, as we know. Fluoride can oxidize all halide particles to halogen in a solution. However, oxidizing power decreases as we move down the group. Why does that happen? the atomization energy of fluorine is very small. This reflects the low bond enthalpy of fluorine. The very hydration enthalpy of the fluoride ion, because fluoride is very small. There is strong attraction between fluoride and the ion molecules. The more the attraction, the more heat is evolved when the hydrated ions are formed. Chlorine can oxidize bromide to bromine and iodide to iodine, as shown in the equation. And bromine can oxidize iodide to iodine, as also represented in the equation. Fluorine as the most reactive element. This element, fluorine, is the only element that is more electronegative than oxygen. It attacks otherwise inert materials such as glass, and it forms compounds with the usually inert noble gases xenon. You know, most times they tell us that inert gases don't react, but you see, with the presence of fluorine, fluorine can react with xenon, and it can react with krypton. It is a corrosive and highly toxic gas. The reactivity of fluorine is such that if used or stored in laboratory glassware, it can react with glass in the presence of small amounts of water to form silicon tetrafluoride, SiF4. The greatest use of fluorine is in the nuclear industry to make uranium-6 fluoride needed to produce the uranium-235 isotope. Its manufacture is therefore crucial for the nuclear power industry. The high reactivity of fluorine allows some of the strongest bonds possible, especially to carbon. For example, Teflon is fluorine bonded with carbon and is extremely resistant to thermal and chemical attacks and has a high melting point. Here we are looking at their reaction with hydrogen and their reaction with water. We can see that fluorine reacts with hydrogen, and this reaction will form hydrogen fluoride, and it is an explosive reaction. Even in cool, dark conditions, the reaction is highly toxic. Chlorine will also react with hydrogen to form hydrogen chloride, HCl gas, and it reacts explosively in solid, and it is toxic. Breathing in gas with more than 50 parts per million of hydrogen chloride can cause death in humans. Bromine reacts with hydrogen to form hydrogen bromide slowly on heating. But even though it reacts slowly like that, it is more toxic than the rest. Breathing in gas with more than 30 parts per million of hydrogen bromide can be lethal to humans. Iodine will form an equilibration with hydrogen or mixture. Iodine is slightly soluble in water. It has the lowest standard reduction potential of the halogens and is therefore the least powerful oxidizing agent among the halogens. The halogens react with water. Fluorine reacts with water vapor to form oxygen and ozone, as shown in the equation. And chlorine reacts reversibly in water to form two acids, the chloric 1 acid and the hydrogen chloride. Bromine can easily be dissolved in water, 35 grams per liter, carbon dioxide, and other organic solutions. When added to water, bromine forms hypobromous acid. Hypobromous acid is a weak acid. It partly dissociates to form hydrogen ions and hypobromite ions. Iodine is not soluble in water. Instead, iodine reacts with water, but the reaction occurs slowly. The water will turn a light orange-brown color. The reaction is is so easily obtained but slowly. Although iodine appears to dissolve, iodine does not actually dissolve in water. Rather, iodine reacts with water to make hypoiodous acid (HIO) and hypoioditic acid (HI). Uses of the halogens. Fluorine is used in drinking water and toothpaste as it reduces tooth decay. It is present in the clay used in ceramics. They are present in chlorofluorocarbons that are used as refrigerants. They are used to generate nuclear power. So these group of elements are really very important since the world powers are after the nuclear powers. Chlorine is used to purify drinking water and swimming pools. It is present in PVC wire insulation. It is used to sterilize hospital machineries. It is also a key factor of certain pesticides like DDT, diphenyl trichloroethane. The halogens of chlorine, bromine, and iodine are often used as disinfectants. Bromine has fire-resistant properties, so it is used to retard flames like a fire extinguisher. It is used to treat pneumonia and Kaiser disease. Methyl bromide is a pesticide that is used to eliminate the spread of bacteria and allows for crop storage. It has a major role in the function of the thyroid gland of our body system, used to clean open wounds because it contains iodine silver. Iodine or iodide is used in photography. Astatine is radioactive. It has helped in the study of cancer. We'll come to the end of this lesson. I will have some study questions for us to undertake. Please try and attempt these study questions. Find out the oxidation states of chlorine, fluorine, bromine, and iodine in the following compounds: F2, BrO2, HClO, BrF3, BrF6, IF5, F5, and IF7. Why is fluorine considered as the most reactive element? Write the electronic configuration of group 17 elements. Write the equation of the reaction of chlorine, bromine, and iodine with water. Thank you for listening to this lesson to the end. I must say that I am excited and I'm grateful that you watched to this end. Don't forget to subscribe, like, comment, and share this video with your friends. Watch out for the next group 18 elements. That is another interesting group to look out for. See you in the next class.